The year is 2029. The place, Boca Chica, Texas. At an exclusive launch station, two towering unmanned rockets called Starships prepare for a 6-month journey into space. Their destination? The cold, barren surface of Mars. Day 1. 2 Starships, packed with more than 100 metric tons of cargo, spew fire and smoke as they launch into Earth orbit and begin their journey to the Red Planet. About every 26 months, Earth and Mars make a close approach, creating an optimal window for faster and more efficient interplanetary travel. For months, the Starships soar through the blackness of space, chasing Mars as it orbits around the Sun. Day 200. After about 6 months of space travel, the Starships enter Mars orbit and prepare to land in the lowlands of the Arcadia Planitia, chosen for its desirable latitude and elevation. Throughout this dusty region, ridges and grooves suggest an abundance of underground water ice, shallow enough for human extraction. Around these icy deposits, the 2 Starships sink their landing gear into Martian soil, forming the foundation of the first human settlement. Day 800. At a small Martian base, robotic payloads run experiments, test critical technologies, and develop infrastructure in preparation for the arrival of human settlers. Meanwhile, the first crewed Starships get ready to launch from the spaceport in Boca Chica. On board is a small crew of highly trained scientists and engineers. Other uncrewed Starships transport essential resources and building materials for radiation shields, landing pads, and power stations on Mars. Soon, Earth and Mars make a close approach, and the Starships blast off from the surface of Earth, thus changing the course of human history. Day 1000. For the first time, an astronaut steps foot on Martian soil, an incredible achievement for humankind. One by one, the astronauts emerge from their Starships and walk with light, bounding steps across the planet's surface, protected by spacesuits from the extreme temperatures and unbreathable atmosphere. As the astronauts gaze across an arid Martian landscape, they consider the unique gravity of their situation, the dangers they'll face on their journey, and the incredible distance between them and their home planet. If something goes wrong, it could take a long time, potentially up to 26 months, before any help or supplies arrive from Earth. To survive on Mars, they must use every resource at their disposal, most importantly the underground deposits of water ice. Water molecules in the ice, when heated with microwaves, detach from the soil in the form of water vapor, which can be condensed and stored as a usable liquid. This valuable resource would satisfy basic human needs, enable agriculture, and maintain critical life support systems. Hydrogen and oxygen molecules, split apart by electricity, can also function as propellant for rockets launching from the Martian surface. Using other local or in-situ resources, astronauts may experiment with 3D printing to create helpful tools, building materials, and other specialty parts. These and other processes may be powered by light energy. Though less abundant than on Earth, sunlight is still a plentiful source of energy on the surface of Mars. Arrays of solar panels generate enough electricity to run sensors and maintain life support systems inside the cabins of each Starship, creating warm, pressurized environments shielded from dangerous solar wind and cosmic radiation. Once grounded, each Starship performs many functions, serving as both research labs and temporary habitats for the first settlers on Mars. Inside one of these Starships, the first designer plants grow in soil-free hydroponic systems. Researchers also experiment with fertilizers that may allow tough plant species to take root in Mars's volcanic soil. Over time, the first astronauts on Mars gradually acclimate to the planet's lower gravity, which can wreak havoc on the human body. Some also struggle with common physiological problems experienced after a long space journey, like muscle weakness and bone loss. The psychological impact of living on Mars also takes its toll, as the first of many planet-wide dust storms sweeps across the surface, engulfing the entire landscape and trapping astronauts inside their cabins for days on end. Meanwhile, on Earth, Dozens more starships are built, tested, and prepared for crewed and robotic missions to Mars. Once the first humans walk on the Red Planet, public interest in interplanetary travel may increase, potentially bringing an influx of money and a wave of people eager to experience life elsewhere in the solar system. Day 2000. Another group of crewed starships enters Mars orbit and lands at Mars Base Alpha, now a cluster of grounded rockets. A second team of Martian settlers, including botanists and architects, steadily developed the outpost into a web of dome structures printed from in situ resources. Some of these structures, dedicated to generating resources, contain small indoor farms. Harsh cosmic radiation could inhibit the growth of plants on the surface, so researchers also experiment with underground farming techniques to generate food more reliably. Other dome structures function as permanent habitats, borrowing electronics and life support systems from grounded starships. Over time, settlers learn to print materials and grow their own food, reducing their dependence on supplies from Earth. Day 3750. The population of Mars Base Alpha has grown to over 100 people, including astronauts from multinational space agencies, both private and government-operated. Along with more settlers, new species of plants and bacteria begin to thrive at the Martian base. Experimental research is conducted on sustainable food sources, including hardy vegetables like onions and potatoes. Although in its early stages, researchers also experiment with raising fish inside aquaponic greenhouses, which recycle water and waste to fertilize crops. About a decade after its creation, Mars Base Alpha approaches near self-sufficiency for basic necessities like food, water, and power. Day 5000. Mars Base Alpha has expanded into a town-sized network of interconnected domes, large and small. Hospitals and entertainment facilities emerge in addition to more spacious residential structures. Advances in technology and the development of infrastructure make life more comfortable on Mars. Some settlers, well adjusted to the Martian environment, choose to stay on the Red Planet indefinitely. The colony welcomes its 1,000th resident, with new settlers scheduled to arrive every 26 months. The number of starships, each carrying 100 passengers, steadily increases at each consecutive launch window, expanding the accessibility of interplanetary travel. However, the population is quickly outgrowing the base's limited infrastructure. To solve this problem, during the next close approach, a tunnel boring machine is transported to Mars. Over many weeks, the boring machine carves infrastructural tunnels and resource pipelines between drilling sites, research labs, and residential domes. These underground tunnels protect workers from radiation while streamlining essential functions like transportation, construction, and manufacturing. To keep up with the expanding infrastructure, settlers must meet increasing energy needs through new forms of power generation. In the early years, most electricity on Mars may come from light energy harnessed by solar panels, but a more diverse system may be required to sustain the base long-term. Plans are drawn up for the first Martian nuclear power plant, a substantial project that may take years or even decades to build. Once completed, a nuclear plant may generate enough power to support human expansion on Mars for decades or more. Day 7500. A new political system governs the growing Martian population and combats problems specific to life on Mars. Broad enhancements to spacesuits increase human mobility across the Martian landscape, and electric rovers, designed to navigate steep grooves and craters, carry settlers to other regions of the Red Planet. New mining operations harvest water ice from the glacial networks of Deuteronomus Mensae. Daring researchers scale the rocky slopes of Olympus Mons, the largest known volcano in our solar system. Below ground, an expanding system of tunnels quickly transports citizens between habitats, farms, and distant outposts, making the Red Planet more connected and accessible than ever. Day 10,000. Nearly 3 decades have passed since the first 12 astronauts set foot on Martian soil. Mars Base Alpha, formerly renamed Mars City, has since become self-sufficient for most essential goods. Water is steadily harvested from underground ice and converted into usable liquid. Solar arrays, wind farms, and nuclear plants generate power for hundreds of diverse structures. Most building materials are reliably generated from in-situ resources, helping this unique settlement evolve into a largely autonomous civilization. If Mars City was suddenly cut off from Earth, its progression might slow down, but its many residents would survive and prosper. Mars City is now home to the first generation of children born directly on Mars. Martian schools teach these children and the many others migrating from Earth how to contribute to the larger interplanetary community. As a generation of Martians spread their wings, a mass migration begins on Earth. Millions of everyday people dream of what life might be like on the Red Planet. Many eagerly await a fresh start in this brand new world of opportunity. Before the next close approach, Mars City prepares to welcome tens of thousands of new settlers, cementing Mars as a second home for our growing species. There's no telling exactly what the future holds, especially on another planet. Any number of factors, like disaster or disease, could disrupt the progress or expansion of an extraterrestrial settlement. But if we succeed, a self-sufficient civilization on Mars may exist only 10,000 days later.